Okay, so it's a very hard act to follow Professor Mahendran Velaythipille. So let me start by saying that he presented something that I think we lack in general in the Sri Lankan scene, that rigor and the theoretical side, and we are much more kind of applied research focused. So my talk is more about that side. Also, I mean, why I'm wearing this, you wouldn't have seen me wearing this much, but you know, yesterday everybody was very formal, and so I decided to wear that, and then everybody else came without their jackets. But since I brought it all the way, I thought I have to wear it. I mean, you know, I shouldn't waste this opportunity. So my talk is about, in a way, it's a bit of an alert. Because I think the people here are people who can influence decision making. And so it's not really a technical talk, but it's more about being aware of what's happening with respect to artificial intelligence. So initially, I think the term artificial intelligence has a lot of hype around it. I just saw recently a tweet by someone who's like really a techie guy, and he said, you know, all these things that they're talking about, machine learning and all, that's not AI. AI is this, and he went on to explain I think the Loebner prize, which is the prize given for any system that is able to pass the so-called Turing test. And so I realized the idea about this is like really not there. So I'll spend a bit of time on that. I'm using AI now and then to mean two things. You know, people are used to talk about AI now and then, but now it's really become important to talk about it. And I'll talk a bit about what is called weak and strong AI. The thing is, whether you believe in weak AI or strong AI, it is here to stay. It's not going to go away. And so it forces us to think about it. And in fact, it's probably one of the few areas in computing that interacts with philosophy. So when we talk about the philosophy of computing, we still don't have one, and I talk about that in our research methods class. We still don't have a philosophy of computer science, but a lot of it is tied up with AI. And so at the end of the talk, I want us to kind of cultivate a healthy skepticism. You know, I still remember someone telling me many years ago, while I was in university, quite something profound. And what he said was, you know, if you want to excel in your field, you've got to have a healthy contempt for it. Healthy contempt. I thought, this guy is crazy. How can you be passionate about something if you have contempt for it? But I really think that the problem with a lot of people is that they are so overtaken by the field they are involved in that they fail to see what a small impact it may have or what dangers it can lead to. So these are the four kind of topics I'm going to talk about. What do we mean by AI? Is it those kind of things that pass the Turing test, or is it something broader? What drives it now? Where is it headed? And what does it mean to us? What does it mean to us? The first one is about definitions, but the last one is about what does it mean to us, where AI is going. So what do we mean by AI? It depends when we asked. So if we asked before roughly the year 2000, we would say something like this: technologies that help solve tasks which were thought to be possible only for humans. And so some of us still hold to this kind of definition. And by the way, there are as many definitions of AI as you can imagine. Right? Yes. But post-2000, if you ask people what is AI about, they'll say that the technologies that seek to create intelligence at or beyond human level. So we'll talk about that under the third topic. What does it mean to have intelligence at or beyond human level? We also have terms for these now. So this is a little bit of history. In the early era, how people got into in the 50s. So soon after computers actually came, people were in. So you can imagine that people thought that once we invent a computer, we can do reasoning. So game playing, theorem proving, that kind of thing was what people tried to do. And the underlying technology for those things was search. And we cover this, I think, in some of our courses on intelligent systems or artificial intelligence. How to search in a meaningful way. And then that led to a lot of kind of expectations. So those breakthroughs led to a lot of expectations, and we say we have had a kind of romantic era, 70s to 90s. And one of the primary focuses there was to make computers understand human language. Now what understand means here is something we will be talking about as we go on. And then knowledge representation and reasoning, and these are all things that conform to something called the knowledge representation hypothesis, which I think comes on in a slide later on. So the major outcome from this era was this so-called expert system, because at the end, this era was a bit of a disappointment because we could only come up with something in a very narrow domain. And so there were some users of this, but not much, not widely adopted by the industry. The main problem was that there is this bottleneck. So instead of the bottleneck being a human expert, the bottleneck became the person who transfers the human expertise into the knowledge base. So it was called the, I forget, something bottleneck. Then we had the modern era where a new kind of pragmatism. Okay, we don't want to create this hell-like computer that can understand us and all. Let's solve useful problems that we have in everyday life. And so subtasks such as speech recognition, language processing, computer vision, expert system, well, not really expert systems, I mean, that's probably something. But the rejection of the so-called knowledge representation hypothesis, which basically said that if something, some piece of software is to demonstrate some intelligent behavior, there should be an explicit representation of knowledge in actually the code. So this hypothesis was rejected thanks largely to things like neural networks, which don't have that kind of central representation. So I've just said the major outcome of this kind of era was this deep blue, this, sorry, I think I've, deep blue, the computer program from IBM defeating the world champion in chess. When the details of this came out, they realized that, okay, this computer was custom built and it had something like so many processors, and so it was looking far ahead of what the human could look and so on. So apparently people like Kasparov can think about 100 moves ahead. I don't know how they do that, but they do some extremely good pruning of the search space. Whereas these computers were doing, I don't know, 10,000 or something like that. And current chess programs do over 1 million, I think, moves ahead. They can kind of figure out. So we are in what is called a postmodern era, and I'm just putting these dates as, after 2010. The dominant underlying technology in this era is learning, and most AI is now led by the industry and not by universities anymore. Web search, recommendation systems, sentiment detection, and things like that. And one of the major outcomes of this is, I don't know how many of you have seen this video, but one of them is the guy who won most amount of money in Jeopardy. The other guy is the one who won most competitions in Jeopardy. Jeopardy is something like Obada Lakshapati, Mamada Lakshapati, that kind of quiz, except that the questions are actually pretty tough to answer for humans. And the great thing here was that the computer was off-the-shelf Linux boxes, so no special hardware or anything, but it had thousands of cores. I think just under 3,000 cores or something. But the more important thing is that it didn't have a database of all these general knowledge. It was just let loose on Wikipedia, Britannica, and so many sources of knowledge. And so it just parsed those things, and it made knowledge structures, primarily I think things like knowledge graphs and RDF triples and things, to extract the knowledge. And from that it answered some amazing questions, and I fully encourage you to watch that video. And I'm not playing any of the videos that I planned because I'm trying to catch up some time that we've lost. So what drives AI? In 2 words, it's machine learning. So previous eras were concerned with encoding knowledge to solve problems, but this one is concerned with techniques that enable the computer to learn by itself. So this is a kind of a nice diagram to put it in an easy way. So initially we said data plus algorithm equals program or whatever. Now it is data and program put in the computer and you get some output. And now we put the data and this output and we kind of get a program. This is the easiest way to describe machine learning. So we are trying to get the algorithm by giving the data and the output. And this is a particular kind of machine learning, but it's a nice analogy to think about this area. So that analogy works for supervised learning, which is learning from data. That means somebody has kind of put the answers in there. So when we have a list of Facebook posts, actually there is something that was done by somebody. Singular posts have some problem. Not only some singular, but you get the Singlish, singular in English. So, and then somebody says this is hate, this is not hate, and so on. Label, this is what it means, label. If you had only this, it is unlabeled, but here it's labeled. And so we get an algorithm to train on them and build a predictive model. So there's a small caveat, and that is that we need to know which features are important when we are kind of trying to build this model. But what if you don't have the answers? Then we say we use supervised methods such as clustering. And this is to make sense of the data without that so-called ground truth, the answers, without the answers. And I think I've given this example to the students, but maybe not to the staff. In India, they had a big discussion about net neutrality, and that we don't even know what this means. It came up because Facebook was trying to sell a package by which Indians could get absolutely cheaply internet access, but internet access through Facebook. So they wouldn't have no other access, but only through Facebook. And Indian the community objected to that because that means internet is not open. So that is what is called net neutrality. Net neutrality means no single company or entity should have control about what you see. So the government said, okay, let's get opinions from the people and ask them to write to an email address with 20 questions. It turned out that 1 million people responded. So 1 million people, as you can imagine, 1 million emails. What do you do with 1 million emails? I mean, you can't not read them because you asked for it. And so the next best thing we could do was, actually it was such a big problem that they opened it as a problem to the rest of the world. And some people here also got interested in this. And so the only thing you could do, because it's unlabeled data, is to do some clustering, and a basic clustering by file size was able to get a lot of noise out of the system. I mean, where people have sent one-liners or one word or whatever. And then there was another cluster which appeared to be same, and when you went and really looked at it, it was like one NGO had kind of done a lot of canvassing and given answers to those 20 questions and asked people to send that up. So you basically, you don't have to read all of them, you know the answer from that. So you read one of them and you know the answer. Then there was another category, of course, was people had written entire policies, about net neutrality. So, but that was a very small number. We have to give it to a human because that's like too difficult for a machine to process. So just using clustering, they were able to kind of figure out there are these 4 or 5 types, and if we know what those 4 or 5 types is, then we can make the job much smaller. When there's more data, generally when there's more data, we can of course use deep learning. What is the benefit of that? We can kind of avoid that human extraction of features, because we normally have to do some feature engineering. So deep learning is about how can you avoid that step. So the algorithm not only learns to predict, it also learns which features are important in order to predict. And of course this may be a structure you've seen for face detection. So different layers learn different kind of features and higher level abstractions until it can recognize a face. So yeah, I think this is a bit important, that generally we need more data for this. When there's no answer but only some clues, so when there's no answer at all, we need supervised learning. Unsupervised learning, but when there's no answer but some clues, we have some clues, then we can use something called reinforcement learning. And this is how humans normally learn. And one of the big use cases is for robots, because robots will go and they get a feedback from the environment when they hit something or when they come close to something, and they need to adjust their path. And so the hot area of application is, of course, self-driving cars. You don't wait till the car goes and actually hits someone, but you know when the driver applies the brakes, you know the scene, you know the events, and so you learn by reinforcement on that. So there's a reward system that just says this is not a good thing. It doesn't give a right answer. It just says this is not a good thing, and the agent learns from that, from the environment. When there's little data, which is the case in language processing for Sinhala and Tamil, for instance, or any other language other than the Latin-based ones, then we can try to use transfer learning. So knowledge of how to translate from French to English, for which there's a lot of data, can be used to translate, let's say, Spanish or Italian or something to English with less data. Actually, so we are looking at how to use this, some of this, to learn for Sinhala and Tamil. So increasingly, few problems are now solved from scratch. Mostly, so most image recognition kind of work uses this ImageNet, a data set that was built for a competition, and then transfer learn from that to your particular application, depending on what you want to recognize. So as you see, two of the main areas of application are this human language and vision, two areas that humans do effortlessly, but computers find very, very hard. Okay? At the other end, things that computers do very easily are things that some humans find very, very difficult to do. So in machine learning, we had this kind of, so this human language is a sequential thing. And so not just human language, but as Professor Mahendran was talking, biological sequences and maybe stock market and things like that, where the sequence matters. We use these kind of models that take account of the order, whereas for vision and other spatial kind of things, we used other kinds of models. And in deep learning, we still have that kind of division between like sequence-based models and these spatial models, non-sequence models. But more recently, so these are based on feed-forward models. The only thing that was not possible for many years was that we didn't have a way of having many layers in the middle because of the so-called vanishing gradient problem. As we backpropagate the error, we are unable to find enough of a gradient to backpropagate. So CNNs were a solution to this. And it turns out that you can use feed-forward models to also solve this kind of problem. So these are like new architectures that are able to use feed-forward models to do language-like tasks also. So these are some examples of those technologies in action, and so these things have come in the last 2 years. I think BERT was 2007, 18 or something. These the OpenAI's language thing, and this is something that is came out this year. These things, these architectures are suddenly able to achieve much, much higher than even the very popular RNN, LSTM kind of models for language. Because somebody asked, are you going to talk about language? So I had to put this one slide about language. Otherwise, we are not really talking about language. What some of these models allow you to do is to also achieve that language independence. So we can build this stuff with Sinhala and Tamil and maybe use some transfer learning to do that. So where is AI headed? It used to be something called weak AI and strong AI. So I was kind of in this group. That means we want AI to help us to solve interesting problems and to remove tedious tasks from humans. But this side is now winning, right? So they are now called narrow and general AI. Weak AI is narrow and strong AI is general. So we were involved in making these kind of things. But general AI is how to create intelligence at or beyond human level. And so that area is called Artificial General Intelligence, AGI, and many kind of efforts such as AutoML and so on are trying to go into this area. We'll talk a bit about that. And some people have seen that this is not enough, so they want to do this. There is a very important book, if you want to read, by someone called Nick Bostrom on artificial superintelligence. So how far are these things? So, how far is artificial general intelligence or artificial superintelligence? People have tried to estimate those, and depending on when they estimated, these things became closer and closer. So this is one experience that made people to bring the date really, really close. Go is arguably the most complex human game. Somebody just estimated it 300 times more as complex as chess. And this guy is Lee Sedol. He was 18-time world champion in Go, Korean guy. And so this is the match he played with Alphago, which is a supervised learning thing. It learned from 30 million moves from 160,000 human games. So they basically collected all the games that they could find and trained Alphago. And in 2016, it made history by beating Lee Sedol 4-1. So it won 4 of the 5 games. But they didn't, this group is actually something called DeepMind, which is a London-based company. But of course, Google saw all this and they bought it. So now it goes as Google DeepMind. So they didn't stop here. That group, in 2017, they made a version of AlphaGo called Alphago Zero that played against AlphaGo. So a system with no knowledge of these past games, but only reinforcement learning. So it played against the one that had the human. And this is a case for training that improves over the teacher or generalizes better than the teacher. So one of the problems with supervised learning is that, of course, you can only be as good as the one who teaches you, right? But here, after training for 40 hours, and of course, the difference is, 40 hours of a computer program playing another computer program means millions of games, right? And then they set up a tournament of 100 games, and Alphago Zero won 100-0. That means every single game it won. So this was like a major achievement. Without any knowledge of these previous games, it was able to just play against the one that had that knowledge and improve and beat it with the 100% record. And then, of course, they didn't stop there. They tried some transfer learning. And they made Alphago Zero into Alpha Zero. That means they removed the Go part, so they did some transfer learning and played with I think, the top chess program. And these chess programs search space of 10 million. I said human can see about 100. These things can see about 10 million. And Alpha Zero basically is a system that the search space was about 10,000. So you can see one order of dimension. Human 100, 10,000 means 100 into 100. And this is 10 million means more than 10,000 into 10,000. And in 2017, again, end of 2017, it won. In chess, there's a lot of, there's something called stalemate. Right? So 72 ended up stalemate. It won 28 of the 100 games and never lost. And this is just after 9 hours of playing these two softwares. So you can see the amazing kind of technologies that made people think, okay, we are coming closer to this artificial general intelligence. What are they doing now? It's an obvious question to ask. And so in the end of 2018, last December, they built a program called AlphaFold for predicting protein folding, and they won that challenge. So they beat every other system in that challenge. So there's a small caveat. These systems have a natural kind of progression, but AlphaFold is not deriving from these. Okay, so it's a different architecture and a different way of solving the problem. And that's important to remember, because of something that we're going to see now. So you can see that there is a kind of reinforcement, and there is a transfer, and there's a lot of things happening. Transfer particularly sounds interesting because, you know, transferring to different areas. But so what can AI do? It's a reality check. Yesterday we had a chatbot workshop, and these chatbots use LSTMs and reinforcement learning. At the question time, I hope she's here. Someone asked me, you know, I have an agriculture application. Okay, so I said, what is it? You know, I want, you know, people will ask questions about, you know, diseases in this plantation and so on. And then I want them to be able to upload an image. And usually they'll upload an image, and a human will look and say, okay, this has this deficiency or this disease or something like that. Can that be done by a chatbot? And so suddenly everything comes in perspective. If you want to solve that problem, you've got to have maybe a supervised learn model to distinguish between some vitamin deficiency and a healthy plant. And to do that, initially you would have to have, let's say, for banana or something, a lot of banana leaves and good ones and one deficient ones, train a model and keep, and then maybe do a bit of transfer learning to do the same thing for pawpaw or something with some more examples, and then and that's all for that particular deficiency. For some other deficiency, then you need to do some more. So you can imagine that solving this problem, which is simple for humans, because a human who would have potassium deficiency may be able to transfer that very easily between the particular kind of plants. But here, suddenly it becomes not easy to do this kind of transfer learning. So AI versus human ability, this generalizability is now the bottleneck. How much can you generalize? So we saw in game playing, very good generalizability, right? How does this extend to other human faculties? And so this is where now a lot of the questions are. So it reminds me, because a lot of people, after the Alphago experience, people started talking about artificial general intelligence is coming, because it was able to learn from one game another game. Reminded me of a trip I went once some long ago. We climbed Adam's Peak, and we came down, and of course some people in the group said, woke up a bit late, and then saw Piduru Talagala. And there's a tower on top of that. And they said, shall we climb this? So we were also, your age, so we said, okay, let's do it. Only thing, we didn't go the proper way, because this guy was a scout, and he said, if you follow this cable, wire, electrical wire, we'll get there in the end, and that's logical. So we started climbing, and we had to clear. He was a scout, so he told us how to mark our way and all that. And we went up. The only thing is, when we saw this, it was like this. In reality, it was something like this. So this is us. And so we climb up like this, and then when you come here, okay, that's not the tower is. So we had to climb down and climb up again this. And we went at least 4 times, right? And hit it. So why I'm saying this is sometimes technology is like that. When the computer was first created, people thought we can make it reason, which is why Arthur C. Clarke famously wrote that 2001, where the computer HAL is able to not just understand what the human says, is able to lip read something that is really hard even now, and is able to understand the emotions of these 2 astronauts. So we are very far from that. So it seems as if it's pretty close, this artificial general intelligence. So difficult to predict how generalizing different games can extend to different kinds of human capabilities. But people have tried to put dates on this, and some of them, most of them say it's before the end of the century. That sounds frightening, no? That sounds frightening. People like Elon Musk say that it's like 2030 or something. Probably they didn't see that mountain having those several ridges. And this is what is called the AI singularities. You know, singularity is a term, I think, coming from philosophy, but most commonly for us, it is about the black hole. You know, when you enter a black hole, everything that you knew before is obviously useless. All the laws, everything is useless. Everything changes, and so a technology singularity or AI singularity means that everything we knew about learning, knowing, intelligence, all this suddenly will change if this happens. We'll talk just a little bit about that later in the last. So irrespective of when this is going to happen, we need to answer what to do. What should we do, or what could we do? So there are these 9 considerations of AI ethics, which I will go very fast, but we should probably discuss at tomorrow's, what do you call, our panel or something, or of course during tea time or lunch time. So the first one is what happens, a lot of people are worried about this. When IT came, people were worried that IT is going to take jobs, but now people are happy. It's not taking the interesting jobs, it's only taking the boring jobs, so they're happy. But when AI comes, it will take some of the interesting jobs also away, right? So you can imagine that guy who sits there and says, you can have the loan, you can't have the loan, becomes redundant, right? If you have enough data, the system is going to make better predictions than that guy. And that guy is a highly paid guy usually. Or the guy who decides what your insurance premium is and so on. So how do we move up the creativity value chain? People say this will free us from those mundane things to some better things. What about those who can't move up that chain? So it's a valid question. Those who aren't creative. Finding meaning in non-labor. Can we find meaning in non-labor activities? I tell some of the final year people, you know, imagine that when you're about to graduate, you hear that a rich uncle has died and left you something in the bank, you don't know, but monthly you're getting 200,000 rupees into your bank account. And the next year you're getting 225,000, next year 250,000, you don't need to, and you also a house and a car and everything. Now what do you do? What would you do with your life? It's a good exercise to think about. What would you do with your life if that is the case? So it's how can you find meaning in life? Now we don't have time to ask this question because we are too busy earning the money, right? But then if you have that situation, we have to like ask this kind of question. How to distribute wealth created by machines? Okay, there's already like a data oligopoly, you know? So the data is the new oil. So it's not the person who has a great algorithm, because most of the algorithms are, you know, open, and why they open it out is because they know that you can't do stuff without data, right? So who are the people who have the data? Google, Facebook, Netflix, Amazon, eBay. These are the people who have the data, right? So only a few people, right? This is a big problem. AI owners will make all the money, right? People who have good AI systems will make all the money. How to structure a fair post-labor economy, and how do you do that? I mean, these are all hard problems, not the kind of problems we can solve by having more complicated neural network architectures. By the way, that's one of the research areas, neural architecture search. Because all these neural networks that we magically get in LSTMs and CNNs, the architecture was almost random, by chance. Somebody, it's an art and not a science. The third area is how to behave and interact with machines. I will not go into this, but this is a software that was, took part in the Loebner Prize, which is the prize annually given to the machines that pass the Turing test. And so this was, and it's always in English, this was done by some Russian people. And it was said to be the first system that passed the Turing test. But soon after that, people started interacting with it and they found lots of problems with it. And so they actually disabled the online interface because it was so embarrassing, right? But we are already doing this with Siri, Alexa, Google, Cortana and things. We are talking to these things. And even if you're not talking, we are interacting because many people probably today came here by looking at Google Maps, because of the Bora conference, right? So without that app, we now don't go to some places. And after some time, it'll be easier to use. And so maybe we have the head mounted, our spectacles will tell us, don't go this way, go this way. And we won't even think about it. Okay, so we are integrated already. Actually, this is interacting, the next stage is integrating. Humanoids are not science fiction anymore. I don't know whether I wanted to play this video, but please go and watch on YouTube. This humanoid is able to make expressions and was given Saudi Arabian citizenship. Okay, but and it makes jokes and so on. But why I'm not focusing too much on this is because in a way it's not general purpose like IBM Watson or something. It's not general purpose, it is kind of specific purpose. How to guard against artificial stupidity. So this is a new version of garbage in, garbage out. We used to learn garbage in, garbage out, input determines the output. But here, the training time input and it determines what kind of system you get. So the higher the levels of abstractions lead to the difficulty of detecting garbage. I think Professor Mahendran was talking about that detecting tanks in the desert. And one of the earliest experiments at MIT was that they trained things with tanks, without tanks, and then of course they gave the label, this has tanks, this doesn't have tanks, trained it and then put some new photographs, and it got it terribly wrong. And so they wondered what happened. It turned out that all the photos they had, without realizing the photos they had put for with tanks were taken in a particular time of the day, and without tanks were a different time of the day. So what the system learned is how to figure out the time of the day rather than whether there were tanks or not. How do we eliminate AI bias? So one of the common things you may have seen is winking Asians with Chinese. So now software is not only detecting in the face, but also detects what you're doing. And so it turned out that many Chinese people were said to be winking by the automatic recognition feature because of their eyes. And through profiling, again, Professor Mahendran was talking about it, most of the blacks became criminals in those by those learning methods. So who will end up designing this stuff and how? Because this is now in the open domain. Anybody can use it to design things that can be have bias. How how to guard against, so this is, each of these leads to the other. So this one leads to, how do you guard against the misuse of AI? This is inadvertent. This is without you knowing the bias. This is deliberate. Okay? So the more powerful a technology becomes, the greater the good and more devastating the bad it can be used for. Right? So this kind of technology is able to do a lot of bad, and we know nuclear technology in the hands of certain people can be really, really dangerous. So here the speed of machines could be against us, because we have to think about these technologies. We have to figure out how they are operating and how we should kind of make them operate. And that leads to an even more difficult problem, how to protect ourselves from AI. Can AI be taught good and evil? Will AI remain true to what it is taught at the beginning, or can it evolve? I mean, a lot of people are trying to see how AI can evolve. Could the good goal of saving the environment lead to human annihilation? This is a big fear, because it's true. Logically speaking, the best way to save the environment is to kill off all the people, because we are the only ones who are polluting it. Animals don't pollute it, right? So how do you kind of give these intents and desires to intelligent systems, which is on the evil side? On the good side, should we define humane treatment of AI? So Hal says, at some point, Dave and his friend in 2001 realized that this guy is too smart for his boots. We are going to switch him off. So they discuss behind closed doors, and Hal is able to read their lips. So at one point, then they decided we are going to disconnect it, and he says, open the door, Hal. And then Hal says, I'm sorry, Dave, famous words, I'm sorry, Dave, I'm afraid I can't do that. Because he knows that they are going to switch him off, right? I won't give any more spoilers, you should watch the movie. So is the humanness of AI different from ours? Will AI require humane treatment in order to be humane itself? Will it learn that from us? What would evolving such humanness look like? So these are, by the way, I'm only posing questions for thought. And then finally, can or should we stay in control? This is an even more fundamental question. Adaptation through ingenuity and intelligence is what brought us to the top of the food chain, not strong muscles or teeth, because those mammoths and all of them were much bigger and were much more agile and all that than human. So this was not the fittest, but the most adaptive. So can or should we remain at the top despite a more adaptive intelligence coming into being? This is a valid question to ask. Valid question to ask. Should we augment ourselves? This is another some people, Ray Kurzweil is one of these very, very strong AI guy. He's all about having super intelligence. He says we should augment ourselves with AI so that it won't be a competition, them versus us. And to some extent we have augmented. So Google Maps is one way we've augmented, and there are so many other things we have augmented already a little bit. So he's talking about implanting chips and things like that. When would we go past beyond the point of no return, and would we be able to detect it? So we augment ourselves, and at some point, do we cease to become human? And that's why the term humanoid has come, something in between human and artificial machine. But will we be able to detect that? Or we will just be in a continuous evolution? And finally, of course, this is the thing that makes people like Elon Musk say, we have to stop this. What happens if AI becomes able to create more intelligent AI by itself? This is, it's where you start thinking, okay, so it's going to create something more intelligent than we created. And then that thing may be able to do that again, and so on. And then very soon the acceleration will, go beyond our point. And this is what is normally referred to as the singularity. There's a Singularity Institute, actually. I think Reiko as well and people have set it up, which is kind of working towards that. So in summary, this pendulum has clearly swung from this narrow to general AI, and people are actually trying to do something more than human intelligence. As with all singularities, there appears to be increasing. The black hole is a place, initially there's no momentum, but as you get closer and closer, you get faster and faster. So there is some kind of effect of that here. So the chances are that it may creep on us unless we are informed and alert. And then this audience, I think, are the people in that space. So there is some global need for slowing down in order for these things to catch up. Ethics and the law are far behind IT, way behind AI. People haven't even thought about, should we do something with AI? So these are a few things, 3 pillars I've put down, but I mean, obviously these are just my ideas. How to kind of have a healthy future. Democratizing data ownership, I think probably one of the big things. We want to keep the data as close to the source as possible. So there are some work on encrypted data machine learning. So you get encrypted data and do machine learning on the encrypted data using algorithms, and then build models. Another is, of course, where you have data with you, and you can give permissions to your company for a certain time or a certain purpose. Your company can give it to the state or something for a certain time and certain purpose, and so on. And so we can expose our data for a particular purpose of, let's say, building a model to figure out whether we are prone to disease, a particular disease. This is a good thing. So we want to share our data for that kind of thing, to build the model, but we don't want that data to go to the insurance people who will then determine what our premium should be. Second one is kind of a global code for ethical conduct of AI. What use can or cannot AI be put to? There are things like this, for instance, for stem cell research, where only certain things can be done. Doesn't stop a rogue nation or a rogue lab doing it, but they will be then kind of blacklisted, so that kind of thing. And today we can see that Cambridge Analytica kind of became blacklisted without something like this. So there is some kind of awareness, and now Facebook is having a lot of things to say, before they can do something now. And maybe some kind of international level treaty to hold governments to account for 2 aspects. One is awareness and education. So, people don't know what they're, people don't know, their rights to our data. That's why we put it all on Facebook or something, no? So I remember last year's keynote speaker, I think, came and said, my wife works for 3 hours a day for Facebook, and everybody thought, oh, okay, so there must be some working from home, remote working or something. And then finally he said, no, she's not paid a cent for it, but she does it anyway. 3 hours a day, she puts content there. So to be more aware of it. So there is a need for, in our education curriculum, to start talking about these things and privacy and things like that. And the other side is, of course, enact laws and enforce them equitably. I mean, very important. Because a lot of people will not be aware, and will not know about technology in order to be careful for themselves. So then we need someone to make them safe. Okay. And this discussion is going on now with respect to online harassment, which is completely different from this, but it's an example of the kind of thing you can do. Okay, so just for those who have some philosophical interest in this, the possibility of non-human intelligence is a kind of a cause for a new kind of ethics to be built. Most terms that we use are human-centered knowledge. When we say knowledge or learning or intelligence, we talk about human knowledge. But now these things can learn, and these things can know. These can be intelligent. Ethics also embedded with humanness, with a little bit of extension to humans, animals. We say, poor fellow, give him some food. We have a little bit of, but it's like a very condescending way, top-down way. And we can do that to the machines also. You better do what we say. But when you watch a movie like Transcendence or something, you realize that okay, we don't know whether we are in control anymore. And finally, what should a new ethics study? And this question can't be answered by ethics. And that's why they say this kind of question in different disciplines, we need philosophy to answer this. So we can't answer this kind of question from inside the system. So we have to think about how do we do this. So this slide is just for people who are interested in the philosophical aspects. And I think we've run out of time, and so I don't think there is time for questions, but I'll be happy to interact during the break. Thank you.